Welcome to the fourth episode of our PX4 based mavlink-router drone show. Now we are one step closer to our real-world drone show, and we are almost ready to take our drones outside and do our first test flights. So let's see how. So far we have covered so much. First, in the first version we created some auto trajectory generator that created some astonishing shape in the sky for us, such as heart, egg, spiral, and we made our drones to fly those trajectories in the sky. Then we expanded our project to not only have one drone, we have more than one drone, and try to fly them in a coordinated and synchronized manner together and create these spiral or heart-shaped trajectories in the sky. Then we use SkyBrush to improve our drone shows, to create any objects in the sky, to create some very advanced animations and shapes in the sky. So all of these video tutorials are available in this playlist, so make sure you follow them and you make sure you covered all the prerequisites, and we know you have a good background to continue to version 0.4. What we're going to cover today is mostly related to the system design and how we should operate the drone show. So we are not going deep inside the technical side and programming. We are dealing with the system design of how we should operate drone show in real world. We are reviewing the system overview of a real world drone show operation and its challenges. Then we're going to create a coordinator and swarm control app. I'm going to introduce two apps for you that is available in version 0.4. One of them is coordinator that is going to be installed on the drone. Another one with the swarm control app, which is our ground station debug ground control station on the ground. The coordinator will communicate with our drone and do the routing, mavlink routing, checking the config files, communication, sending the state and telemetry to the ground station, getting the telemetry and the commands from the ground station, and do all this sort of stuff. For this case, we're gonna create a software in the loop coordinated simulation. But what is different between this software in the loop simulation and the simulation that we had before? In the last simulator, we had all the drones in one simulator and everything was happening on one PC. But now we're gonna simulate that we have 5 different nodes here. 4 of them are drones, 4 different drones on 4 different virtual machine on VMware workstation. Each one has their own operating system, own software in the loop, own system. Everything is separated. And another Windows-based ground control station, which is our swarm control app, will take control of all of this and synchronize this drone show. Let's see how it will work. From an overall system overview, this is what I have just mentioned. We have a ground station, which is the box in the center. It consists of 2 sections. One of them is the old Q ground control drone control system. You can use Q ground control, you can use mission planner or any other mavlink based ground control station. Another custom application that has been added to this version is swarm control app, which is our debug ground station app, which is now based on a console, but will be updated to a GUI later on, and eventually these 2 applications will be merged. So swarm control application would be a part of Q ground control station. I'm going to merge it together so we have only one application on our ground control station. This node has an IP, has a private IP address which is 192.168.189.1, and we have plenty of drones. For this test we're going to use 4 drones. Each of them have different IP address, and each of them are on a different operating system and different system. 192.168.189.131 for drone 1, 132 for drone 2, and so on. Let's go deeper and see what is happening inside each drone. Inside each drone, we have several communication happening. First of all, we have the conventional mavlink out and mavlink in. Mavlink would the ground control station can connect to the drone using UDP port on port 14550 plus I. This I is drone ID. It means the drone 1 is going to be communicating on the port 14.55.1. And the drone 2 would communicate on the port 14.5.52, and so on. There is another communication protocol here that is based on UDP as well, which is our swarm control. And that is happening on the port 13.5.4T plus the drone ID. The drone 1 would be basically 13.5.41. Eventually, again, these two would be merged and we won't need to send our swarm control data on a different protocol or on a different port. We will make the mavlink-based telemetry packets and merge them together to only have one communication between the drone and ground control station. And also the swarm control protocol can be expanded to send data to all the drones. For example, the drone 1 can send telemetry to the drone 2 and drone 3 as well. So the drone 3 can understand and know the state of drone 1. But right now in initial version, each of the drones are operating individually and don't know about themselves. Only the ground control station know the state of the telemetry and if needed send commands to the drones individually. There is also a web server that the drone can communicate because the drone have internet access. So when initially they want to start up, they will check the world clock and they synchronize the system clock, so the drones all have the synchronized time, and they will check the web server to get the latest config.csv. So all of them would have the latest config.csv that we have created. In the heart of the drone, there is a PX site eventually in the real world. But in this example, again, we have a separate individual software in the loop that is running and showing the simulation on JMAVSim. So it doesn't matter if you have a PX site or software in the loop. If you have a PX site, the coordinator application would connect using serial, or if you have a software in the loop, this coordinator would be connected using UDP on port 14.5.50. The coordinator would do a lot for us, but I'm gonna mention a few of them. The coordinator will take care of initializing, synchronizing the time, getting the config.csv, checking the configuration, checking the state of the PX site. It will wait for the commands. It will wait for the command, the trigger command, the schedule mission commands from the ground control station. It would also take care of the routing the mavlink packets for us. It will use the mavlink-router. So you need to install mavlink-router by yourself. It's something out of this package. We will install the mavlink-router and the coordinator will use the mavlink-router to route the mavlink packets to the different location that we need. It gets the data from the software in the loop and the PX site, then it will route it to the ground controller station and will also route it to the off-board mav SDK application. So the coordinator will also have a communication on port 14.5.4T on a real hardware with the off-board mav SDK application. In software in the loop environment, you don't need to do that because it will automatically create another instance of mavlink on port 14.5.40. Another thing that coordinator take care of is triggering the mission. It's very important that all drones trigger the mission at the exact same time. Otherwise, there is a risk of collision or the shapes in the sky would not be the exact shape that you expect. So the coordinator will take care of this challenge. It will get the trigger time from the ground control station and sync it with the world clock and trigger the off-board mav SDK application at the exact time. During the mission, also coordinator can get the position and state of each drone and send it back to the Q ground control as well. This is the initial version, basic version. A lot of features would be added in the near future, but this is a basic operation of a drone show, and the main part of this project is the coordinator. Coordinator is taking care of most of the jobs behind the scene, and the off-board mav SDK application only take care of riding the drones. So it starts riding the drone just like how you ride a horse. It knows it has a CSV that in each time it has specified its position, velocity and acceleration, feed forwards, also the LED colors and flight modes. So off-board mav SDK thinks that it's the only drone on the show. It doesn't know anything about other drones. It only just gonna ride the drone through a predefined trajectory. But the coordinator take care of synchronizing these drones and make sure they are doing as they should. So I think it's enough with talking. Let's see how it works in action and follow along with us in this video. Before continuing of our simulator, let's see and review what animation we're gonna see. We're gonna use the skills that we learned in the last tutorial, and very basic, just take up 4 drones, 2 movements and 1 rotation, and then return to home. Let's see how it works on a SkyBrush viewer. If you're not familiar with this stuff on a SkyBrush viewer and SkyBrush Studio, go ahead and watch the last tutorial that we went through all these menus and create an example. These are the plots for this 4 drone: proximity, altitude, vertical speed, and so on. And we can also go to the viewer and see the animation. This is gonna be what the animation will look like in real world if we do everything as expected. Okay, let's export it to the CSV. And then we're going to use our process formation script that we used in the last tutorial, and we're going to convert the SkyBrush files to our own templates. 4 files have been created. This is a plot for each drone: drone 3, drone 1, drone 2, and this is the plot for all drones. Make sure all drones have returned to their home position and landed correctly, so we can verify that the drone trajectories are okay and they are not colliding with each other. Okay, now we are ready to process to our software in the loop environment. As you can see, we have 5 different systems here. Each of them are a different system and a different virtual system. Drone 1, drone 2, drone 3, drone 4, all of them are Ubuntu, and on the right side you have the Windows-based ground station. Each one of them have a different IP address. Let's see, for example, for drone 1, let's type ifconfig and see the IP information of this node. Obviously 192.168.189.131, and similarly for the drone 2 we can do that as well. I'm gonna fast forward this part of the video so you can see that everything is the same for each drone. Each of them are separate. Obviously, we can ping from each one of these nodes together. For example, pinging from the ground station to one of the drones. For example, drone 1. We have to ping. We can also confirm that we have pinged with drone 2, drone 3, drone 4, and so on. Next step is to confirm that all of these drones have the mavlink drone show GitHub repository installed in them. So as you can see, I have cloned the GitHub repository on each of them and synchronized the version together, and the only difference that they should have is this file. Each one of them has a file called, for example, 4.hwid. Each one of these files shows to the coordinator that which drone is this one, because the coordinator file is the same. It's gonna run on all of the drones. It's gonna read this file and understand on which node it is. This is an empty file. Only the name of the file is important, which is 1.hwid for drone 1, 2.hwid, and all of these files should be available on near the coordinator file, so the coordinator knows which file it is using. On the ground station, you need to open the debug GCS test, and you can connect to the drones. Let's clear the terminal sections. We're gonna seed it to the PX4 firmware. Each one of this node, as I told you, have the PX4 environment installed. So if you don't have them, go ahead and watch the last tutorials how you can run up your own software in the loop simulator. So each one of them has this JMAVSim gazebo PX4 software as well. So I'm gonna fire up the JMAVSim since it's a bit lighter than gazebo. I'm gonna run it on all 4 nodes. Drone 1 is ready, and I'm gonna do the same on all 4 drones. So we have 4 software in the loop simulator. All I did on this section that I fast forwarded is just arrange the screens to make all of them look the same, clear the command console, and we are all the same page with all drones. So next step is to check our debug GCS test. Make sure the configuration, the boolean configuration is okay. You should select single drone to false and sim mode to false, because basically we are not in sim mode, although we are doing a software in the loop, but they are all in their own separate system, so we are not on sim mode, and we also are not doing single mode. We're gonna run the debug control station, and as you can see, it run, and it basically go ahead and read all the IP and port information from config.csv, and it's already telling you that it's listening and sending on which IP and which port, and now it's waiting for the commands to come from each drone. You can run the Coordinator.py from the drones itself, but make sure you do the configuration on them. The sim mode should be false, serial mavlink should be false, because we are not going to use serial, we are going to use UDP. And if you want to get the latest config file, you have a web server, you set the offline config to false and online synchronized time to true if you want to sync the time. But I've already downloaded the config files and synced the time, so I just disabled that. And now what you have to do is to just run the Python coordinator Python files on the screen. For simplicity, I opened the Visual Studio Code on each of the nodes, so you can see that all of them are the same. Basically, you don't need to run Visual Studio Code, it's just a bit heavy. You only have to run the Python code. But let's have the VS codes here. I'm gonna open the Coordinator.py file on all of the drone. I just wanted to demonstrate that all these files are the same. The only difference is that on the drone 1 we have 1.hw.id, drone 2 we have 2.hw.id, and all as it is. Okay, let's run. The drone 1 is running, and as you can see, the telemetry is coming from the drone 1. The drone hardware ID and the position ID is 1, and it's already sending telemetry data to the ground station. Now that we run drone 2, the telemetry packets from drones 2 should also appear on the right hand ground control station. And here it is. You can see now we have one from ID 1 and one packet from ID 2. They are sending in a 2 sample time of 2, so each 2 seconds we get a telemetry packet. Now let's run the coordinator for drone 3. And now we should have telemetry from ID 3 as well. Here it is, 1, 2, 3, again 1, 2, 3, and so on. And we're gonna do the same for the drone 4. In real world, the coordinator will be on the startup.rc of the Raspberry Pi or your operating system, so it will automatically run when your system boots. You don't need to manually run it. Okay, drone 4 is initiated, and now we should have 1, 2, 3, 4, again 1, 2, 3, 4, and the telemetry are receiving from all drones. By the way, this is the first time I'm testing this script with 4 drones. Let's trigger, as you can see, I triggered the mission for 10 seconds or 20 seconds from the trigger time. Now all the drones have a trigger time, as you can see on the screen, and at the exact same time they will be triggered and will start to do their flying. They initiated, As you can see, all of them, the mavlink, the off-board control had started, and here we go. The drones have takeoff, and all of them thinks that they are only the only drone on the show. But the ground control station and the coordinator know that there are 3 other drones and they are being synchronized together. As I told you, this is the first time I'm testing this scenario with 4 drones. I have been testing it with 1 drone, but this is the first time that I'm testing with 4 drones or more than 1 drone, and it's very exciting for me as well. We have the telemetry on the right side, telemetry for 1, 2, 3, 4, the state of the drone, and we can see the drones doing the flight. And you can also have the Q ground control station. In my setup, I open Q ground control station on another computer, since as you can see the screen already is messed up and everything is tiny and small, and I hope you can at least see what is happening. The Q ground control station is better to be run on a different display and different screen. Here it is, our first successful almost real world operation of the drone show. Right now we see that our coordinator at debug control station also works, so we can work and improve it. Okay, that's it. As I told you, we are almost ready for the real world operation. We have come so far from the version 0.1 to here that we are almost ready for the real world flight. But as I told you, it is not still ready. There are lots of challenges with this kind of operations. There are lots of risks and challenges that I try to discuss on the first video. Off-board control and drone controls are very challenging and risky, so make sure if you want to do something like this, consider everything, consider plan B, consider your drone suddenly go crazy, you lost connection to the drone, so always be ready and have very safe plans. I already discussed this challenge and risk on first tutorial. This project is improving, will be updated with the next video. I don't know when, maybe in near future, maybe no, depends on when I can get the drones ready for real world flights, or maybe I want to show you how you can create very advanced animation using SkyBrush. But make sure you have followed this YouTube playlist. There is a YouTube playlist called Swarm and Drone Show, and it should already have 4, and it will be improved, and other videos will be added to this playlist. Make sure you have followed it from the first episode, so you know what we are doing, and you know the concepts, and you know the prerequisites, and every other things that you need for this project, such as running up your PX4 environment, running your WSL, knowing the concepts of software in the loop and hardware in the loop, and knowing the concepts of PX4 are already available in my YouTube channel, so make sure you follow them. And if you have any suggestion for this project or any other videos for the future, please let me know in the comment section below. Until then, thanks for watching and good day.